Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon, and we are in our third week of our 9-week course. At this point, you should be thinking about work to submit. So a reminder that the support questions, the ones with the pencil icon, are not for marking. You decide which ones and how many to do. If you are understanding a concept, feel free to skip questions. You don't have to do them all just because they're there. The answers are in the back of the booklet, so check your work. This way you know if you're on the right track or if you're struggling with something. So please use them. There's no point in copying the answers for the support questions because I'm not looking at them. They are really just there to help you learn what it is that you're doing. So check your work, but use it to actually help you learn. The key questions are the ones with the key icon, and these are the marked questions. So do all of these questions, showing all of your work, your steps, and your thinking. This way I can truly understand what it is that you understand. And if you are struggling with something, it gives me more information about what it is that you're struggling with so that I can actually help you. So how do you actually submit your work for marking? Well, there's 3 different ways. The first way is to scan your work and send it electronically. You can scan your completed work with a device. If you have an Apple device or an Android device, you can use the apps that come with them. The Apple device use the Notes app. The Android devices use the Google Drive app. These are free apps that generally come with the devices, but you can also download if you need to. And then a fairly straightforward point and click scanning capability. If you're unsure how to do this and you'd like to learn, on my YouTube channel, I have tech tutorial videos that walk you through how to use both of these apps so that you can actually do this. If you just need to take pictures because that's the only option that you have, that's fine. Scanning just makes the file smaller and a little bit easier to send. But if you need to do pictures, that's okay. Then you can send it to me through email to studentwork@nnec.owen.ca and CC it to bronwyn.slate@nnec.owen.ca. Or you could also send it to me through Facebook Messenger, where my name is bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So just put your work in there at any time and we'll get it back to you as soon as we can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslatewahsa. So you can friend me on Facebook or subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded and I post them to YouTube shortly after airing. So all of the information is there for whenever you need it on your own time. Also on my YouTube channel, there are short videos that explain common errors and confusing concepts. So this is a good place to go if you're struggling with something and you need to just look at one particular concept. There are short videos that are just bite-sized that can hopefully help you if you need to. Math is a really visual subject, so I strongly encourage you to access the videos. Either joining me live for Zoom or watching the replays on YouTube is really going to set you up for the most success. Just listening to me talk is not going to get you the full experience, and most likely you're going to walk away being confused. So connecting to the videos is really, really important. If you don't have reliable internet and you can't access the videos on your own, let me know and I'm happy to send you a recording of the videos so that you still get the full experience. If you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslate-wahsa. You can call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m., though I work teach the last hour of my day, so that is not a good time to try to get a hold of me. All right, we are diving into lesson 7 today, and this is compound interest and exponential growth. Lesson 6 was about simple interest and linear growth. And so this is a continuation of, not a continuation, but sort of the next step. So it's really important to understand lesson 6 first before moving on to lesson 7, just because it builds on lesson 6, though it is a different concept. All right, our learning goals for this lesson are that you will be able to understand the final amount when an investment or a loan's interest is compounded, and you'll understand the relationship between compound interest and exponential growth. The success criteria is that you can identify the principal, interest rate, compounding periods, and time in order to find the final amount, and you can graph compound interest growth. So when we'll use this in real life? Well, we are making connections. So a large part of math, the study of math, is making connections from one concept to another. And in life, a lot of things are about making connections in order to strengthen the way you want your life to be. So this is a super important skill, is making connections between things in your life. But before we dive into our concepts today, let's activate your brain with some mental math. I don't believe in mad math minutes. They are stressful and focus on speed and memorization, which are not the fundamental elements of math education. So instead, we focus in this course about developing strategies that we can use in various situations that help us become comfortable and confident using and manipulating numbers. Our question today is 16 plus 18, and we're using the concept of near doubles. So doubles are when you double a number, and this is something that are fairly common and makes a lot of sense to most people. So near doubles is when you are using the concept of doubles, but your numbers are not quite doubles. So we have 16 plus 18. So we could either double 16 or we could double 18, but I'm going to even think of it slightly differently, and I'm going to say, well, this is close to 15 plus 15. And I know 15 plus 15 is 30. That's something that my brain just is comfortable with. So in order to get from 16 to 15, or no, from 15 to 16, I need to add one more. And in order to get from 15 to 18, I need to add 3 more. So that means I didn't actually add all the amount that I need. I need to add another 4 more to 30 in order to get the full amount. So 15 plus 15 was close, but I still need to add another 4. So that means that my total is actually 34. So 16 plus 18 is equal to 34, based on the idea that 13 plus 13 is equal to 30. And that's the idea of using near doubles. So finding numbers that are friendly for you, that help you break your problem up into even friendlier numbers. All right, mine's on. What do we need to engage with that we already know? I just want to do a quick recap of simple interest, which we did in lesson 6. We're going to be using this to build our understanding of compound interest. So it's important that we understand what simple interest is. So remember, we use the formula I equals PRT, where I is your interest amount earned in dollars, P is your principal invested or borrowed, also in dollars, so the amount of money that you start with. R is your interest rate per year. And T is your time in years. And this, from lesson 6, we explored and we discovered that this is linear growth. We are increasing or decreasing your amount by a constant rate. So every time you're adding the same amount. Over the same time period, you're adding the same amount or subtracting the same amount. And so you get a linear, a straight line graph. All right, so now we're going to dive into our active learning. We're going to explore our new concepts of compound interest. This is more money. Basically, compound interest basically is just talking about various ways that money is in our lives. So it could be student loans, borrowing money for your education. It could be investments and how you hopefully make more money. That's the concept of an investment, is that you're investing money to make money. Your money's making money for you. But it's also how credit cards can be used. So some loans, some can be simple interest, but many loans and many forms of debt are compound interest. So understanding how this works is really important. So before we dive into the compound interest formula so that we can just calculate it, we're going to understand what it actually means by connecting it to simple interest. So looking at the example, what happens when $1,000 invested for 7 years at 5% simple interest? So we're going to use a chart to organize our information. For each year, we know that the principal is $1,000. That's how much we invested. The interest is 5% of $1,000. So that's $50. So then the final amount is 1,000 plus 50. So $1,050 is how much money you now have. So year 2, it's the same thing. We invest that $1,000 we invested is all that gets invested. The interest is still $50 because it's still 5% of that $1,000. So our amount now we add another $50 to, so it's $1,100. And this continues for year 3, 4, 5, 6, and 7. Every year our principal is still the same. We are investing $1,000, therefore we are making $50 for that year. Therefore, every year we are increasing by $50. So we end with $1,350 after the 7 years, which means that we earned $350 by investing this $1,000 in simple interest. So if we do the same thing, but we compound our interest, so when we invest $1,000 for 7 years at 5% interest, but we're compounding it yearly. So what that means is that, let's look at our chart again. So year 1 is exactly the same. We still are investing $1,000, we make $50. So therefore at the end of the year, we have $1,500. Sorry, $1,050, my bad. In year 2, this is where it changes. So now instead of our principal being $1,000, we're going to take that interest that we earned in year 1 and we are going to reinvest it. So we are going to, our principal now, when we compound, our principal now is $1,050. We take our final amount from year 1 and we invest it in year 2. So now our interest is 5% of $1,050, which is $52.50. So when we add that to our amount, now we have a total amount of $1,102.50. In year 3, now we invest the final amount that we had in year 2. So we invest $1,102.50, which means if we do 5% of that, that is $55.13. So our final amount after year 3 is $1,157.63, because every year we're making a little bit more money because we're investing that interest that we earned. So year 4, where our principal is $1,157.63, which 5% of that is $57.88, which if we add it to our principal, our final amount for year 4 is $1,215.51. Year 5, we invest $1,215.51. 5% of that is $60.78. Add those two together and we get $1,276.28. Year 6, we invest $1,276.28. 5% of that is $63.81. Add those together and we get $1,340.10. And then for our final year, year 7, we are investing $1,340.10, which means 5% of that is $67. Add those together, we get $1,407.10. So after 7 years, we now have a total of $1,407.10, which means we earned $407.10. So if we compare these two methods of simple interest to compound interest, in simple interest for the 7 years, we earned a total of $1,350, which means we actually earned in interest $350. With compound interest, we have a total of $1,407.10, which means we earned $407.10 in interest. So we earned $57.10 more just because of compound interest. We did not start out with more money. We did not do it for a longer period of time. We did not do it at a higher interest rate. We didn't add more money into it as we went. The only thing that was different is that we compounded our interest, which means that we earned money on the money that we already earned. So we had free money on top of free money. So this is really, really important to realize if we think about it in a longer time. We looked at it only on for 7 years, but if we looked at it for a much longer period of time, here on this graph I have, if we take an amount, $1,000, we compound it for 10 years, sorry, 10% for 20 years, my bad, 10% for 20 years, we can see the principal is the amount of money, the $1,000 that you invested. So you don't earn that. That's just how much you start with. So with simple interest, we can see we have this red line, this red piece, which is a straight line increase. After 20 years, we're at $3,000, which if we take away the $1,000 that we started with, we earned $2,000. Great. But with compound interest, you can see at the beginning, you don't earn that much more, a little bit more, but not a ton more. But by 20 years, now we are over, a total amount is over $7,000, which if we take away that $1,000 that we started with, it's going to be over $6,000. We earned $6,000. It's 3 times the, double the, no, 3 times the amount. I was right, because this is 2,000. 3 times the amount that we would have earned if we did simple interest, just because we reinvested the interest that we already earned. And that's how people who invest, how people make a lot of money with investments, because they are investing compound. They're making money off of that money that they made. They're reinvesting their money. So compound interest is exponential growth. As you can see, we have this curve, which is the same as the exponential functions that we've been talking about. And so it grows, it gets faster and faster and faster and faster as we go. So to understand compound interest, remember that it is interest that is calculated on the principal and the earned interest. It is exponential growth. You can think of it as free money from free money. This is really great for investments. This is how you make money in investments, but it is not helpful if you are borrowing, because that means that you owe money on the money that you already, on the interest that you've already owe. So it's that the amount of interest that you're paying adds up, and that's not good. So it's great for investments, not good for borrowing as a person, as an individual. So then the next question is, well, can we get more free money? Because I don't know about you, I definitely want to get more free money. So we know that compound interest earns more than simple interest. That's what we just did. But the more frequently we compound, the faster the interest adds up. So remember, compounding is how often we reinvest that money, that interest that we just earned. So if we look at this on a graph, we can see that if we compound once a year, so that means that we reinvest all of our money once a year, we have this red line. It is still exponential, it still grows, but we're only reinvesting once a year, so it's not super fast. Faster than if it was linear, but not super fast. If instead we compound monthly, then it means that if we look at this blue line, which to start off with does not seem impressive, you don't even see it, it's just a bunch of lines. But as you can see, this blue line increases much faster than the red line. So in reinvesting your money, that money that you make in interest every year, compared to every month, is a lot less money than if we do it every month. So if we reinvest our money every month, then we're going to be, that interest is going to be earning us money opposed to just sitting around. If we do it by weeks, then we are going up this green line. So it is a little bit faster than the blue line, the monthly line. And if we did it by days, then it is even just a little bit faster. So you can see that more frequently you compound, the more money you're making because you're reinvesting that money constantly. So you're always adding to the amount of money that you're investing. So what that means when we're looking at the numbers and calculating them is that we need to pay attention to the compound frequency. So this is the compounding period. That means the time frame in which the compound interest is calculated. So how often you're reinvesting your money. So compounding periods are often less than a year. They're generally, we don't compound something for more than a year. We don't invest it after a year. We always invest it at least a year. But there's some language that we need to know in order to understand if we're doing it more frequently than a year. So if we compound annually, that means we do it once per year. So the number of compound periods in 1 year is 1. If we compound semi-annually, that means we do it twice a year. So our number of compound periods per year is 2. If we compound quarterly, there are 4 periods of compounding per year. We do it every 4 times a year. If it's monthly, then it's 12 times per year. If it's weekly, then it's 52 times a year. And if it's daily, it's 365 times a year. So understanding these words, recognizing these words and knowing what numbers they translate into, that they communicate, is super, super important because you're going to be using these numbers in your formulas, but these words are going to be what's telling us which numbers to pick. All right, so let's dive into the compound interest formulas. This is on page 9 of your IL booklet. They mostly just dive into the formula. I like to give you a little bit of a why in order to help us understand how we got here, but we're now going to dive into the formula. So our formula is A equals P times 1 plus I quantity squared. So the 1 plus I is in brackets, and that is what we're, not squared, to the power of n. That's what we're raising to the power of n. So it's a little bit awkward to hear. It makes sense when you're looking at it, but means that the order of things matter and what you're applying the exponent to is important. So A is our final amount. This is how much money we have in total, including our principal. Our P is the principal amount, so the amount of money that you have invested or that you have borrowed, because remember, this is how it applies to loans too. Principal is what you start with. I is your interest rate, and this is a decimal. And this is the tricky part. This is what's is really different from simple interest, is this is per compounding period. So the interest rate as a decimal, like we did before, but now we're dividing it by the number of compound periods in 1 year. So if your interest is compounded quarterly, that means we're dividing it by 4 because our interest rate is going to be compounded frequently 4 times a year. But that means that how they do it is that they break that interest rate into 4 parts. And then N is the total number of compounding periods, which is equal to the number of compounding periods per year times the number of years. So that is the formula that many folks, that has been like sort of the traditional formula for compound interest. Recently, there's been a new formula that has been created, which you might see in your booklet if you have an old booklet. If you have a newer booklet, then this is the compounding formula that you will see. So this is A equals P times, open a bracket, 1 plus R divided by N, close a bracket, N times T in the exponent. So A is still our final amount. P is still our principal invested or borrowed. R now is your rate, your interest rate expressed as a decimal, and N is your number of compound periods per year. So this is the exact same information as in the previous formula, but now we say it explicitly. Instead of saying I and then you having to think about that as your rate divided by your number of compound periods, that is all just right in your formula. And then T is your time in years. And again, N is still your number of compound periods per year. So this, after the first step, this is all going to look exactly the same. If you use either of these formulas, it's just a matter of which formula is easier for you to look at and for it to make sense when you start. I'm going to use the second formula because it keeps things clear for me if I break everything up by these 5 variables. So if we compare formulas, we have the same thing. A is still our final amount. That's what we're finding. P is still our money, our principal, money invested or borrowed. Then R over N is your interest rate divided by the number of compound periods, whereas I is your interest rate divided by number of compound periods in 1 year. So it's exactly the same thing. It's just that we can either write out explicitly the division or have it sort of hidden. Then NT is your number of compounding periods times time, and N in the second formula is the number of compound periods times the number of years times your time. So again, it's exactly the same information. It's just that it's written more explicitly in the one that we will be using and the one that I've updated the booklets to use. But if you have an older version of the booklet, then you might still have the A equals P times 1 plus I to the exponent N. And this one you still might see in like an old textbook or something, but more and more we are seeing this newer one where the information is more explicit. Okay, so that's great. That's the formula. But what do we actually do with it? So let's look at an example. An amount of $4,000 is deposited into a savings account at a rate of 7% compounded monthly. Calculate the total balance after 5 years. So what I like to do, just like before when I was doing simple interest, is I like to write down all of my variables so I can figure out what it is that I know and what it is that I'm looking at. So this question says calculate the total balance, which means I'm looking for the total amount, which is A. So that's what I'm trying to find, trying to solve for. Then P is my principal, which is $4,000. That's how much I started with. R is my rate, which is 7%. So that's 0.07. N is 12 because it's compounded monthly. And T is equal to 5 because it's 5 years. So now I have all of my variables and I can put them into my formula. So I have A equals P times 1 plus R divided by N, all to the exponent NT. So once I write down my formula, I can fill in all of the information that I know. So I have A equals 4,000 times, open a bracket, 1 plus 0.07 divided by 12, close a bracket, to the exponent 12 times 5. Now you can simplify this. You can not just do that whole thing in your calculator, but break things down to have A equals 4,000 times 1 plus 0.00583 to the exponent 60. You can totally do that if that's what makes sense. if that makes your life easier. However, if you're going to do the division and your decimal is more than 5 places, I would strongly keep it in your calculator to make the most accurate calculation. I would try not to round it off too much. If you do need to round it off to at least 5 decimal places. 5 or 6 decimal places is going to get you a much more accurate answer than 2 or 3 decimal places. So just keep that in mind. Then we calculate that and we get A equals $5,670.50. So the total balance in the savings account after 5 years is $5,670.50. So remember, that's how we would do it. Compounding is great for investments, but also remember it applies to loans and debts. So that it can, depending on the details of the loan. So let's look at an example when it is credit. So number 2, Xavier's credit card balance is $800 at the beginning of July with an interest rate of 19.99% compounded daily. He forgot to pay his bill until the next month. How much interest did he have to pay? Because this says compounded daily, I know we're talking about compound interest. We did a very similar question like this in lesson 6, where it said with an interest rate of 19.99% simple interest. So that told us that it was simple interest that we were going to be doing. This might not say compound interest, but it will say compound daily. It has to tell you how often you're compounding it for it to be a compounding question. So that's really important to recognize when you're looking at these questions. So we want to know how much interest he had to pay. Well, remember with compounding, our compounding formula, we figure out our full amount. So our amount is equal to our principal plus our interest. So our interest is what we're looking for, which means we had to figure out our amount first. So our principal is 800. Our rate is 19.99%, so 0.1999. N is equal to 365, which is compounded daily. T is equal to 31 out of 365. So because it is in days, right, from the beginning of the month to the end of the month, which is there's 31 days in July. So, but want it to be per year, right? So that's why we have to divide it by 365 in order to make it in years. So then we use our formula. We put in all of our amounts. So A is equal to 800 times 1 plus 0.1999 divided by 365, all to the exponent 365 times 31 divided by 365. So that means we have A is equal to 800 times 1.00054 to the exponent of 31, which is equal to $813.69. Now, does that answer our question? No, because we were asked how much interest did he have to pay. That includes our principal. So to figure out how much interest it is, we have to remember that amount is equal to principal plus interest. So interest is equal to amount take away principal. So we have $813.69 take away 800, which means we have interest is equal to $13.39. So Xavier has to pay $13.39 in interest for the credit card balance that he carried in July. So it's super important the reason why we write sentences at the end of word problems is that it helps us remember to make sure that we've actually answered the question. If we would have just put $813.69 is how much you paid in interest, that might have clued you into the fact that there was more that you needed to do. Okay, so let's just keep doing a little bit more practice. A principal of $250 is invested at 12.5% compound quarterly for 6 years. Calculate the accumulated interest at the end of each year. So sometimes these questions want you to practice by breaking it up into what it would be like each year. So we are looking for how much interest we have, which means we have to find the amount so we can take away the principal. And we're going to finally piece of information that we need. So we have principal is equal to $250. Our rate is 12.5%, so 0.125. Our compounding period is 4, it's compounded quarterly, and our time is 6 years. So at the end of each year means that we're not actually doing it for the 6 years in total. We're going to change that year by year. So instead of putting this in, you can put all these numbers in, and instead of putting in for your T, for your time, you're going to just leave that for right now. Because then what you can do is you can change it for each year. So when you have year 1, you're going to do 250 times 1 plus 0.125 divided by 4, all to the exponent of 4 times 1, which is $282.75. Then to figure out the accumulated interest, we subtract $250 to get $32.75. And then you can continue with now figuring out what it is for at the end of the second year. So here you can use still the same formula, but it's just that instead we're going to be substituting 2 into our exponent for time instead of 1, which was for 1 year. So this is $319.79, which means your total accumulated interest is $69.79. In year 3, year 4, year 5, year 6, you're doing the same thing. You're using the same formula, but every year you're changing it to be if you did it for 1 year, 2 years, 3 years, 4 years, 5 years, or 6 years. And then this pays attention to the fact that you've already reinvested money, and so it figures out how much it's going to be just at the end of that year. So then part B, you're going to draw a graph to show the growth of this investment. So we're going to compare the year that we've invested to the accumulated interest, how much interest that we made. So if we do this, we can see that as you plot these points over time, you can see that we actually have exponential growth. We're growing faster and faster every year. I use the free Desmos graphing calculator, which we talked about before. It can be a really useful tool to do this in order to get an exact result, opposed to doing it by hand, which can always be a little bit tricky. So I'll link it as always in the show notes, and there are free apps to use on a device if that works better for you than a computer. So then it says, part C says, use the graph to determine when the accumulated interest is $100. So what that means is that we look here and we say, okay, how long will it take us to make $100? So that's our interest. So then we go across to our graph here where it hits it, and that's going to be at 2 and 2 3/4 year. So we go across from 100 down, we get 2.75 years, which is when your investment will have accumulated $100. So that's how you can read it off of a graph. All right, now you are ready to do the practice problems on page 13, 1 to 3. Okay. Let's do some more practice problems to just really make sure that this makes sense. Number 1, if a person invests $2,500 at 5 3/4% for 7 years compounded annually, calculate the investment of maturity. So this means to do it to figure out how much money you're going to have at the end. So how we do this is we're going to figure out what we need to know. So A is equal to how much we have at the end. This says calculate the investment at maturity. That's how much do you have at the end. P is equal to 2,500. R is equal to 5.75%, which is equal to 0.0575. A 0 really makes a big difference if you leave it out of your decimal. N is compounded annually, so that annually, remember, is 1, and T, our number of years, is 7. So then we're going to put it into our formula. So A is equal to P times 1 plus R over N, all to the exponent NT. I do not expect you to have this memorized, but I do feel like it's really valuable to write it down in order to make sure that you have your information organized correctly. I have it memorized because I've done it so many times as a teacher, but you do not need to have it memorized. So once we have all of our information, we fill it into our various variables. And now I like to just put it all into my Desmos calculator. This is what works for me. You can do it what works best for you, but I like to put it all in my Desmos calculator as 1, because then everything is there. And then if I make a mistake, it's easy for me to see and I don't have to go back for multiple steps. So if I put it into my Desmos calculator, you also get used to it over time, and you remember where you need to have brackets and where you don't. So that is $3,697.45. So the investment would be worth $3,697.45 at maturity. There we go. All right, number 2. A person has $3,500 to invest at 6.25% compounded quarterly for 3 years. Calculate the amount due. So what that just means is the final amount. So as always, we are looking for A, not as always, but we write down our variables. P is equal to $3,500. This means that if you, when you're doing your work, if you write down your variables and I can see that you had all your variables correctly, then I know that gives me information about what you understand and what you don't understand. Okay, so rate is 6.25%, so 0.0625. N is your number of compounding periods. So this is compounded quarterly. What does that mean? That means 4. So N is equal to 4. Then T is 3 years, so T is 3. The same reason with writing down your formula. Eventually, we're going to have more than one formula. So, I mean, we already do really. We have your simple interest and your compound interest. Sometimes I've had students who just continue to use simple interest, and if they write down their formula, then I understand what it is that they're doing, that they're understanding. They don't understand that compound interest is different than simple interest. So that's why it's really important to show all of your work, because then I have a better chance of understanding what it is that you are doing. Okay, once again, we've got it all written out. So we're going to put it into our calculator. So 3,500 times, open a bracket, 1 plus 0.0625 divided by 4, close a bracket, to the exponent of 4 times 3 is equal to $4,215.69. All right, part B, calculate the interest earned on the investment. So we're trying to figure out how much interest we have, which means that we are looking for interest, which is equal to the amount, take away the principal, which is equal to $4,215.69, take away $3,500. You can do this using some of our mental math skills if you want, or you can just use your calculator if you want to do that as well. So we have $715.16. Sorry, and 69 cents. That's how much interest this investment made. Number 3, a person wants to invest $300 for 10 years and has 2 options. Which plan should the person choose? Plan A, 3.2% compounded semi-annually, or plan B, 2.7% compounded weekly. So we need to do this twice to compare. So I think it's super important to organize your information so that I know what it is that you know. I can probably figure out what it is going on if you write a big jumble of numbers on the page, but that is not going to make my life easier, and I don't want to assume anything. We're trying to figure out which investment they want to choose. We're going to assume that they want to make them more money. That's what an investment is. An investment generally is you're wanting to make money. So we're looking for the total amount that is higher. Our principal is $300. Our rate for plan A is 3.2%. So that is equal to 0.032. Our compounding period for plan A is semi-annually. So that is twice a year. So 2. And our time is 10 years. So A is equal to P times 1 plus R over N to exponent N T. So 300 times 1 plus 0.032 divided by 2 to the exponent 2 times 10. Okay, so that on our calculator, it can get kind of boring to put the same thing in your calculator over and over and over again, but hopefully it gets so boring that you are super comfortable with it and you know exactly what it is that you are doing. So we get $412.09. So that's what investment A is going to give us. Investment B, we're still looking for A. Our principal is still $300. Our rate this time is 2.7%, which is equal to 0.027. Our compounding period is weekly this time. So that means it's 52 times a year. And our time is equal to 10 years. It's still for 10 years. So here you can see we are comparing, if we change the rate, we make the rate lower. So we're not earning as much money because the rate is lower. But we increase the compounding period. We're compounding more frequently. Which one's going to make us more money? And that's often what the case is that you might have these different variables to consider and not being sure which one you want is going to make you the most money. This is how banks and things, loans, try to make more money off of you because they make it confusing. So 300 times 1 plus 0.027 divided by 52 to the exponent 52 times 10, which is equal to $392.96. So, assuming that we want to earn the most money, plan A is better. Having a higher interest rate that is not compounded very often is better than having a lower interest rate that is compounded more frequently. So plan A makes more money. And should be chosen. There you go. All right. So this question, we don't have time to do the whole thing, but looking at this question, it says Shu Ying invests $750 at 5% per year simple interest. Her sister Shu Jin invested $750 at 5% per year compounded annually. Who earns more interest in 10 years? So in 1 year, these two sisters are going to earn the same amount of money, but over 10 years, the Shujin who compounds it annually is going to make more money in the long run. So it's better to compound than not to compound. All right, let's consolidate. Let's go over what it is that we have learned today. So lesson 7 is compound interest and exponential growth. So we've learned that compound interest grows exponentially, which means that it has the pattern increases or decreases at a constant ratio. We're always multiplying by the same amount, just like when we were looking at exponential functions. Our formula is A equals P times 1 plus R over N, all to the exponent NT, where A is our final amount, P is our principal, rate is our interest as a decimal, time is our, T is our time in years, N is the number of compounding periods per year. And then also interest is found, the amount of interest is found by doing our total amount, take away our principal. So hopefully you can identify the principal, interest rate, compounding periods, and time in order to find the final amount. And you can graph compound interest growth so you can understand how it grows exponentially. All right, that is our lesson for today. In lesson 8, we continue with compound interest, and we're looking in that one, we're looking more at the formula in terms of, well, what if you are trying to find the, you know, the final amount, but you want to know the rate or the principal or the time period. All of that is going to be, we're going to look at that in lesson 8. So we'll dive a little bit deeper into this formula. If you have any questions, please reach out and connect with me. You can call me at the office at 807-737-1488, extension 2209. You can call toll free as well at 1-800-667-3703. You can send me an email at bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca. Connect with me through Facebook, where my name is B Slate Wahsa, so feel free to message me there. And also you can check out this video as well as all of our previous lessons on YouTube, where my channel is B Slate Wahsa. All of our lessons are under a playlist called MBF3C. That's our course code, so everything is there. My office hours are Monday through Friday, 9 a.m. to 3 p.m., except on Thursdays when it's actually 10:15 to 4:15. So reach out and connect with me if you need support. I'm here to help. This is the primary purpose of my job, is to support you. So please, if you need support, let me know. Thank you so much for joining me today. I hope you have a lovely day. Which